Okay, guys, so this time we are going to discuss the Bernoulli's energy equation or mas kilala sa tawag na BEE. Okay? So this Bernoulli's energy equation for me, this is one of the most powerful equation na makikita nyo sa hydraulics. So usually, ginagamit siya sa mga problems sa hydraulics. So alamin muna natin, sino ba itong naka-invento ng Bernoulli's energy equation? So Bernoulli's energy equation, so this was discovered by or developed by Mr. Daniel Bernoulli. So isa siyang Swiss mathematician and physicist noong 1752 and siya rin yung naka-discover ng law of conservation of energy. So this is the principle appropriate for fluids. And this determine the sum of all energies and bulk. So when we say energy, so dyan papasok yung work, yung potential energy, and yung kinetic energy. So, nung kanina, under the continuous flow, sa mga flow rate natin, so di ba inintroduce yung law of conservation of mass? So, dito naman, ang gagamitin natin is yung law of conservation of energy. So, paano ba siya mas madaling mauunawaan? So, let's just say, gawa ulit tayo dito ng stream flow, kung saan, wait lang. Let's just say na magkaibang level yung ayan. Okay, so as you can see, magkaiba yung level ng kanilang flow. And let's say that this is 0.1. And this other point, this is 0.2. So it's very obvious here that yung area nila is different with each other. So I will name this as my area 1 and this one is area 2. So area 2 is much smaller compared to area 1. And if gagawa po tayo dito ng reference datum, ayan, this is the datum line. So yung distance nila, so let's just denote this as our Z1. Ayan. And then this one is Z2. Okay? So, ito yung magiging streamline natin. So again, coming from the center. Ayan. So, from the energy equation, so itong conservation of energy or the law of conservation of energy. So, ang function niyan is to determine the sum of all energies involved. So, again, dyan na nga papasok C. So, sulat ko na natin equation. So, the total energy is equals lang do sa work plus yung potential energy and then plus the kinetic energy. So, let's just name this as our A. This one as our B, and then this one as our C. So, unahin natin yung A or dun sa work. Okay, so ang work, ano nga yung equation natin for work? Di ba ang work mo can be written as the force times the distance, D. Okay, so kung kukuha ka ulit dito ng strip, yung parang ginawa natin kanina. Ayan. Okay. So, assuming that yung area nito, though hindi siya mukhang equal. So, sabihin natin na equal siya. So, the distance between these 2 points, so yung parang ginawa lang din natin kanina, ano? So, sabihin natin siya as distance D. Okay? And knowing that the force is just, the work is equal to force times distance, meaning, if this is your object and meron ka ditong force P, force, gawin na lang natin F para kapareha dito. So this force F, it tends this body to move at a certain distance, T. Ayan. So yan yung explanation dyan. And since ang pinag-uusapan natin dito, this time pala guys, under Bernoulli's energy equation, so i-consider na rin po natin dyan yung magiging pressure na madidevelop dito sa flow na ito or ito sa stream flow na yan. Okay? And ito, meron din velocity. So, i-consider natin siya. And we all know that yung pressure mo, so saan nga equals yung pressure? So, di ba, pressure is a unit of force over area. Okay? So, if isa-substitute mo siya dito, okay? So, if you're going to solve for F, di ba ang F is just equals to P multiplied by A. Therefore, yung equation na to will become P times area multiplied by the distance. Okay? And this area times distance na yan, di ba ito yung tinutukoy niya dito. Di ba ito is A and ito A din. So yung area times distance na yan, ano yan? Di ba yung kanina, equal siya dun sa ating volume. Okay? So therefore, this equation will now become the pressure multiplied by the total volume. And ang mangyayari dyan, if i-relate natin siya doon sa kanyang fluid properties natin na density or yung rho, di ba ang rho is just equals to the mass over volume? And if you're going to solve for the volume, that is equals lang sa mass over rho. So in short, itong work mo, another variation na equation na yan, will be equals lang do sa pressure P multiplied by the mass nung dumadaloy na tubig all over the rho or the density of the fluid flowing in this stream. Okay? So, ito yung ating magiging equation for the work in terms of pressure and the density. Now, this time, ang gawin naman natin is yung considering this B or the potential energy. So, ano nga equation natin, guys, for potential energy? Di ba ang potential energy, if you're going to recall from your physics, ano pa ba ito? And also sa dynamics mo, di ba ang potential energy has an equation of potential energy is equals to mass times the gravitational acceleration multiplied by the height. Pero dito, ang i-consider nating height, so yung Z ang gagamitin natin or yung point kung saan coming from the datum up to the distance na ina-analyze natin. So let's just say na ito yung point na yun and pangalanan natin siya as distance Z. Okay? So ito will be equals to mass times the gravitational acceleration G times Z. Okay? So potential energy, ito na lang yung gamitin natin na equation para with respect dito sa diagram na ginawa natin. Okay? And for C, or for the kinetic energy, yan ay magkakaroon ng equation. Ano nga yung equation natin for kinetic energy? Diba yun ay equals sa kinetic energy or KE is equals to 1/2 times the mass times the velocity squared. So gawin na lang natin dito ng bar para ma-distinguish natin yung velocity and yung volume. Okay? Kasi pareho sila ng symbol eh. Yung isa small letter V lang and yung isa capital letter. Okay, so knowing that ito yung ating magiging equation dyan, so therefore, yung total energy natin, considering this equation na na-produce natin, so i-rewrite mo lang itong equation na to, dito. So the total energy will have equation of pressure multiplied by the mass all over the density plus the potential energy or the mass times the gravitational acceleration times the height na Z plus 1/2 of the mass times the velocity squared. Okay? And as stated sa law of conservation of energy, ang sinasabi kasi dito is that yung total energy mo from point 1 should be equals lang sa total energy mo in point 2. So if you're going to write that in an equation, so ganito yung makikita mo sa equation na yan. Okay? So, as per the law of conservation of energy, ayan. So the total energy in point 1 will be equals lang sa total energy in point 2. So if you're going to write the equation for that, so gawin mo lang to, copy mo lang yan, and then etong mga P, etong mga Z, and itong velocity, lalagyan mo lang ng 1 and 2. So, i-simplify lang natin. So this will be P1 multiplied by the mass. So yung rho naman is constant, no? Kasi isang fluid lang naman yung dumadaloy dyan sa stream na yan. Plus mass times the gravitational acceleration times z sub 1 plus 1/2 of the mass times the velocity of 1. So lagyan ko na lang ng bar ha, squared, is equals to the pressure in point 2 multiplied by the mass all over the rho plus mg. So, mangyayari lang dito, mapapalitan yung 1 ng 2. And then plus 1/2 of mass times the velocity of at point 2 squared. Okay? So, as you can see here, lahat ng natin, value has a mass. So, therefore, we can cancel out this term. And ang next goal natin dyan is to cancel the density. Etong wrong. Ito. So, ang gawin mo lang, just multiply both sides by rho. Okay? So, now, our equation will be equals lang sa P1. Teka lang, gawin ko ulit blue. So, maa-cancel na to. So, that will be equals to P1 or the pressure at point 1 plus the rho times the gravitational acceleration times Z1 plus rho b sub 1 squared over 2 is equals to P2 plus rho times the gravitational acceleration Z sub 2 and then plus rho times b sub 2 squared all over 2. Okay? So, before, ang nangyari kasi dito is yung height o yung distance away from the datum is magkaiba doon sa point 1 and point 2. So now, ang gawin na lang natin dito, considering this equation, so gagawa tayo ng panibagong senaryo. So ang gagawin ko, yung potential energy is papatayin ko na. Ang goal kasi natin dito is i-relate yung relationship or yung dito. Tama, yun nga. Yung magiging effect, yung relationship ng pressure with respect to sa area and velocity. Okay? So, para lang mas maunawaan nyo kung anong mangyayari kay pressure if mabilis yung velocity and paliit yung area. Okay? So, i-determine muna natin yun. Kasi mahalaga yun eh. Para malaman mo din kung saan point mas malaki yung pressure. Okay? So, gawin natin, unlike doon sa kanina, ang mangyayari ngayon is pagpapantayin natin yung iyong stream flow or ganito yung magiging itsura niya. Ayan. Ayan. So, this is your point 1 and then this is your point 2. A1, A2. And then, if gagawa ka ng streamline coming from the center again, and then this is your datum. Tama? So, this is the streamline. So, yung Z mo at point 1 is equals lang doon sa Z doon sa point 2. So, ibig sabihin, itong term na to will be cancelled out. Tama? So, mangyayari dyan, kung makakancel yan, ang magiging equation natin, ito. So, matitira na lang dyan is what? So, di ba matitira na lang dyan is yung P1 plus rho times B1 squared all over 2 is equals to P2 plus rho times B sub 2 squared all over 2. Okay? And ang gawin natin, pagsamasamahin natin yung common term. So, itong P1, this will be transposed sa other side natin. And then ito, this will be transposed dito sa point ng equation na to. Okay? So, gawin natin ang function kasi dito o ang goal natin is to make a positive value. So, di ba yung velocity dito sa point na to, dito sa V2, mas mabilis siya, di ba? Mas malaki yung value niya. Kasi nga, pagliit ng area, pagtaas ng value ng velocity. So, para maging positive value yan, and alam natin yung V sub 1 mo is smaller value. So, yun yung nilipat ko dito. Ibig sabihin pala, yung pressure at point 1 will be greater compared do sa pressure dito sa point 2. Ano? So, ito kasi yung itatranspose natin doon. So, kung mas malaki yung P1, so kung itatranspose natin itong P2 dito sa kabila, ibig sabihin, mas malaki yung value ng P1. So, ang ibig sabihin pala niyan is that, paano ba? So, again, yung area ng point 1 mo is greater than do sa value ng area do sa point 2. So, if that is the case, yung velocity sa point 1, since malaki yung area, will be less than sa velocity do sa point 2. Okay? So, pagtaas ng area, so pagliit ng velocity. And pagliit ng value ng area, paglaki ng value ng velocity. So, kaya ganito yung nangyari natin. So, to simplify that equation na yan, so P1, so transpose natin minus P2 is equals to, so factor out ko na lang yung rho. So, rho over 2, and the quantity of B sub 2 squared, and then minus B sub 1 squared. Okay? So, next, so, ang gawin na lang natin, dagdagan na lang natin to. So, ang learning pala natin dito, ayun nga, yung gaya na sabi ko kanina. Ayun nga, if paglaki ng area, pagliit ng velocity. And based on this equation na na-produce natin, itong equation na to. So, anong nangyari dyan, if yung pressure mo, ayan, so yung P1 mo will be greater than dun sa P2. So again, kapag malaki yung area, maliit yung velocity, pero yung pressure niya will be greater. And then, kapag pagliit ng area mo, syempre, pagbilis ng velocity, pero yung pressure na nangyari dyan is mas maliit. Okay? So, ito, importanteng importanteng detalye to, lalo na kapag may mga venturimeter kang kino-consider dyan. Kasi yung venturimeter, ginagamit yan para ma-measure yung pressure between 2 points. Okay? So, to make the story short, ang gawin natin dito. Therefore, so the pressure is reduced o bumababa siya when the velocity increases. Okay? Increases in flowing fluids. So, dyan, papasok yung Bernoulli's theorem. Okay? So, ano yung sabi sa Bernoulli's theorem? So, the pressure reduced when velocity increases in a flowing fluids. Okay? So, isang magandang example dito, guys, is yung sa water supply natin. So, for example, meron ka ditong water source. So, ano ba isang magandang example ng water source? So, dito sa atin is yung prime water. So, meron ang source dito. And then, dito, syempre, magkaaroon ka ng pump. So, ang goal ng pump na yan is to supply water on different households. So, for example, yun yung sinusupplyan nyo. So, may mga tao dyan. Ayan. So, kapag yan, sa pagdami ng tao mo, syempre, pagtaas ng consumption o pagtaas ng demand sa tubig. So, pag lumaki yung demand ng tubig mo, syempre, yung value ng flow rate mo will also increase. And we all know that if your flow rate is increasing, therefore, considering na yung area nitong mga pipe na to is uniform, therefore, your velocity is also increasing. Okay? So, if Q or the flow rate is increasing, therefore, di ba increasing din yung velocity? Therefore, yung pressure mo is bababa. Kaya guys, kung mapapansin nyo, for example, lalo na kapag tanghali and ngayong summer is mainit. So, meron kasi mga area kung saan, syempre, sasabay-sabay na gumagamit ng tubig na yan. Yung tubig sa mga gripo nyo, kung mapapansin nyo, mahina na yung tulo. Kasi nga, bumababa na yung pressure niya. Ano? So, ayan yung relevance niyan and yung relationship ng bawat isang yan. Okay? So, let's proceed with the next topic. So, this time naman, yung energy head na tinatawag. So, ang mangyayari lang dito is that coming from this equation kanina, eto, i-convert natin siya into a corresponding equivalent height. Ano? So, yun yung tinatawag nating energy head. Okay?